So in this video, I'll discuss the formation of complex ions in solution and some calculations on the complexation equilibrium. Okay? So complex ion formation is a Lewis acid-base reaction that results in the formation of a coordinate covalent bond. Okay? So sa isang Lewis acid-base reaction, meron tayong Lewis acid, siya yung nagre-receive ng electron pair. Tapos meron din tayong Lewis base, siya naman yung nagbibigay ng electron pair. So the electron pair donor is most probably the ligand, or it's usually the ligand. Tapos yung central atom nyo or the metal is the Lewis acid. Okay? So nagpo-form siya ng complex ion. So kapag may charge, it's an ion. Kapag walang charge, it's usually a salt. Okay? So yung salt na yon is either soluble or insoluble based on its characteristics. So the complex is very stable due to the following. So there is a reduced acidity of the cation and the reduced basicity of the ligands. So since hindi na masyadong acidic yung cation kasi naka-receive na siya ng electron pair, tapos hindi na masyadong basic yung inyong ligands kasi siya ay nag-donate na ng electron pair, so nag-i-increase yung stability niya. So hindi na siya nagre-react sa ibang species doon sa solution. Okay? So also, there are closed shell electron configurations dun sa ating ibang complex. So kapag closed shell electron configuration or kapag yung ating molecular orbital ay fully filled na yung kanilang mga bonding orbital, okay, stable na sila. Okay? So, hindi na sila magre-react further dun sa ibang species dun sa solution. So the KEQ of the complex ion formation is known as the formation constant. Okay? So kapag formation, nasa reactant side yung Lewis acid at yung Lewis base, yung product nila na complex ion ay nasa right side. Tapos yung KF is given here. So that's the concentration of the product complex ion over the reactants, which are the Lewis acid, yung Eg+, in this example. Tapos yung ammonia, which is the Lewis base in this example. Okay? Also, formation constants are very large due to the greater stability of the coordinate covalent bond. So this is based on the molecular orbital theory or the principles of chemical bonding. Okay? So kapag ka nag-form tayo ng bond, okay, bumababa yung energy ng ating system because of the formation of the bond. Okay? So therefore, mas nagiging stable yung ating system compared doon sa mga unbonded state. So also, the bonding of the ligands can be described in terms of the stepwise formation constants. So kapag ka nagde-describe tayo ng formation ng ating complex ion, isa-isang ligand lang yung kumakabit muna. Okay? So pwede natin siyang i-describe as that, or pwede natin i-describe as the net attachment of all the ligands doon sa ating central metal. Okay? So as an example, meron tayo dito reaction. Okay? Yung silver plus, kakabit siya sa isang molecule ng ammonia via Lewis acid-base reaction para mag-form ng monoamine silver cation. So the KF is given right here. So that's the concentration of the monoamine silver cation over the concentration of silver plus times the concentration of the ammonia. Okay? That's KF1 kasi this is the first ligand na kumabit doon sa ating central metal. So for the next ligand, okay, so for the next ammonia, kakabit ulit siya dun sa silver. This is the silver complex in this case, okay, para mag-form siya ng diamine silver plus. So the KF for this is given by this expression. So concentration of the diamine silver cation over the concentration of the monoamine silver cation times the concentration of the ammonia. That is KF2 kasi this is the second ligand na kumabit doon sa ating complex. Okay? So pwede rin natin siyang i-describe through the net reaction. So i-add nyo lang reactions na to. So pag in-add nyo yan, magka-cancel lang yung monoamine silver. So magkakaroon tayo ng ganitong net reaction. So the silver plus will react with two molecules of ammonia to form the diamine silver cation. Okay? So the KF is just the product of KF1 and KF2. So KF1 times KF2 siya. So kapag in-express natin yung product, we will multiply the expressions. Okay? So makaka-cancel dyan yung monoamine silver. Tapos ang matitira dyan ay yung the rest ng ating species. So as a product, okay, that's the concentration of the diamine silver cation over the concentration of the silver cation times the square of the concentration of your ammonia in the system. Okay? So katulad ng sinabi ko kanina, matataas usually ang value ng ating formation constants. But the stepwise formation constants generally decrease due to the increase in the coordinate covalent bonds in the complex, which causes crowding. So kapag parami na ng parami yung ligands na nakakabit dun sa inyong complex, yung susunod na kakabit na ligand ay mahihirapan na due to the electron pair repulsions. Okay? So for example, we have this nickel 2+. Okay? May kakabit sa kanya na ethylene diamine to form the ethylene diamine nickel 2 cation. Okay? So the KF1 for this reaction is 2.399 times 10 to the 7. So kapag naman yung susunod na ethylene diamine ay kakabit doon sa complex, magpo-form siya ng bis ethylene diamine nickel 2. Okay? So the KF2 is less than the KF1. So that's 1.514 times 10 to the 6th. Okay? That's less than this value, the KF1. So kapag kakabit na yung pangatlong ethylene diamine doon sa bis ethylene diamine nickel 2, magkakaroon na tayo ng tris ethylene diamine nickel 2 na cation. Okay? The KF3 is less than KF2. Okay? Kasi mas mataas na yung crowding sa tris ethylene diamine nickel 2 at sa bis ethylene diamine nickel 2. Okay? Tapos kakabit pa yung ating ethylene diamine. And yung ethylene diamine natin ay bidentate. Dalawa yung sites na kumakabit dun sa ating nickel. So mas mahirap gawin yung ganong klase ng complexation. Okay? So here we have some sample problems. So for the first one, calculate the equilibrium concentration of the diamine silver plus if 20 ml of 0.05 molar silver nitrate is mixed with 10 ml of 0.10 molar ammonia. So the Kf for the process is 1.66 times 10 to the 7th. So for the first step, calculate the concentrations of the silver plus and ammonia after mixing. So for the concentration of the silver nitrate, which is also the concentration of the Ag plus in solution, okay, that's 0.05 molar, okay, initial concentration times 20 ml, initial volume over the final volume, which is 30 ml, based on the 20 ml plus 10 ml here, we will get 3.33 times 10 to the negative 2 molar for the silver plus. For ammonia, that's 0.10 molar, that's the initial concentration, times the initial volume, which is 10 ml, over the 30 ml final volume, we will get 3.33 times 10 to the negative 2 molar. Okay? So for the next step, let's construct the ice table. So since nakalculate na natin yung mga concentrations after mixing, yun na yung ilalagay natin dun sa ating initial concentrations. Okay? So upon change, mababawasan ng x molar yung ating silver plus, mababawasan ng 2x molar yung ating ammonia, at madadagdagan ng x molar yung ating diamine silver plus, which is the product. So these are the equilibrium concentrations. So isa-substitute lang natin siya dun sa ating Kf expression. So the Kf expression is concentration of the diamine silver plus, which is x, over the concentration of our silver plus, which is this one, 3.33 times 10 to the negative 2 minus x, okay, times the square of the concentration of ammonia, which is 3.33 times 10 to the negative 2 minus 2x squared. So upon solving x, okay, we will get 0.01637 molar. That's also the concentration of our diamine silver plus based on the ice table. Okay, so for the concentration of the silver plus, that's 3.33 times 10 to the negative 2 minus x, that's 0.01692 molar for the silver plus. For the ammonia, that's 3.33 times 10 to the negative 2 minus 2x based on the ice table, we will get 5.436 times 10 to the negative 4 molar. Okay, so aside from the typical ice table, we can also assume that since malaki yung value ng Kf, yung reaction natin ay nagpo-proceed to the right. Okay? At nauubos yung ating limiting reactants. Okay? So, since masyado mataas yung Kf, pwede nating i-assume na one-sided lang yung reaction. So, that would be the basis for our alternative solution. So, let's assume that the complete reaction is possible due to the high value of the Kf. So, using that concept, we will use stoichiometry to determine the amounts of the products based on the reactants. So, gawin muna nating basis yung concentration ng silver plus. So, from the 3.33 times 10 to the negative 2 molar of silver plus, multiply natin siya ng mole ratio, which is equal to the molar ratio kasi pareho lang naman yung volume. Okay? So, for 1 molar of silver plus, makakaproduce tayo ng 1 molar ng diamine silver na complex. So, as predicted, mapoproduce natin ay 3.33 times 10 to the negative 2 molar of the diamine silver plus based dun sa ating silver plus concentration. So kung ang basis naman natin ay yung ammonia, that's 3.33 times 10 to the negative 2 molar ammonia. Okay? So i-multiply natin siya ng molar ratio, which is the same again dun sa mole ratio kasi pareho naman sila ng volume. So for every 2 molar ng ammonia, makakapag-produce ka ng 1 molar ng diamine silver because dalawa yung amine or yung ammonia doon sa ating diamine silver na cation. So kapag sinolve nyo to, you will get 1.665 times 10 to the negative 2 molar of the diamine silver cation. Since mas konti yung nakalculate nating amount from ammonia, ammonia is now the limiting reagent. Kasi mas konti yung nakalculate natin, so yan lang yung kayang maproduce given the amount of the ammonia. Okay? So ito na rin yung ating magiging predicted amount ng diamine silver plus. Okay? So since yung ammonia natin yung limiting reactant, we will assume that ammonia is completely consumed after the reaction. So this will be basically 0.00 molar after the reaction. Okay? So for the silver plus, gaano kaya karami yung silver plus na natira after the reaction? So the amount of silver plus remaining is equal to the initial amount of silver plus minus the amount of the silver plus that was consumed. So para makalculate natin yung silver plus consumed, we will calculate from the product here. Okay? So the 1.665 times 10 to the negative 2 molar ng diamine silver times yung mole ratio between the silver plus and the diamine silver. So, dapat nasa numerator yung silver plus. So, kapag kinalculate nyo yan, makukuha nyo yung Ag plus consume. Okay? Kasi based dun sa amount ng product, malalaman natin kung gaano karami yung Ag plus na nagamit. So, para makuha nyo yung Ag plus remaining, isusubtract nyo lang yung initial amount minus yung ating amount of Ag plus consumed. So, kapag kinalculate nyo, you will get 1.665 times 10 to the negative 2 molar ng Ag plus remaining in solution. So, that's how you calculate using the alternative assumption that since Kf is very high, the reaction will proceed to the product side, okay, and will consume the limiting reactant. Okay? So for the next example, calculate the equilibrium concentration of the thiocyanato iron 2 complex after mixing 20 ml of 0.05 molar potassium thiocyanate and 5 ml of 0.05 molar iron 2 nitrate. So the Kf, or the formation constant for the process, is 20.417. So for the first step, let's calculate the final concentrations. So for the concentration of the iron 2 plus from the iron 2 nitrate, that's 0.05 molar, okay, times the initial volume, which is the 5 ml, over the final volume, which is the 25 ml, that's 5 ml plus 20 ml, you will get 0.01 molar iron 2 plus. Okay, so for the thiocyanate anion, that's 0.05 molar, okay, initial concentration, times the initial volume, which is the 20 ml, over the final volume, which is the 25 ml, you will get 0.04 molar thiocyanate anion from the potassium thiocyanate. Okay? So for the next step, let's use the ice table to calculate for the equilibrium concentrations. So for the reaction, that's iron 2 plus the thiocyanate anion forms the thiocyanato iron 2 complex. Okay? So these are the initial concentrations that we have calculated. Okay? So upon change, X molar yung mawawala doon sa ating Fe2+, X molar din yung mawawala doon sa ating thiocyanate, and then magpo-form yung X molar ng thiocyanato iron 2 complex. So these are the equilibrium concentrations. So, let's just substitute these equilibrium concentrations doon sa Kf. So, for the Kf expression, we have the concentration of the iron or the thiocyanato iron 2 complex at equilibrium over the equilibrium concentration of the iron 2 plus times that of the thiocyanate anion. So, these are the substituted expressions. So, X for the thiocyanato iron 2 complex, this is for the Fe2 plus, and this is for the thiocyanate. Okay, so if we solve for X, we will get the concentration of the iron thiocyanate or the thiocyanato iron 2 complex. So that is the 4.221 times 10 to the negative 3 molar. Okay, so for the concentration of the iron 2 plus, that's 0.01 minus X, you will get 5.779 times 10 to the negative 3 molar. So finally, for the thiocyanate anion, you'll get 0.04 minus X, that is based on the ice table. You will get 0.035 molar. Okay, so that's my discussion on the formation constants, the properties of the complexation equilibria, and some of its characteristics. So dun sa susunod kong video, I'll discuss electrochemistry and its basic principles. So see you next video.